All right, so for this video, we're going to talk about graphs that are proportional versus those that are not proportional. So I'm going to go ahead and read this first part to you. It's very simple. A graph is proportional if it forms a straight line and goes to the origin. The origin is the point in the middle of the intersection of the x and y axis. It's labeled 0, 0. So I'm going to show you the origin. That's the origin, that's the origin, that's the origin, okay? Right there where the 0 is your origin. And what you're going to do now is determine which graph is proportional. So you're going to look for straight lines, and you can tell each one of these are straight lines. So we can't decide based off of that. Now I need to find the one that has a straight line and it touches the origin. Well, this touches, it doesn't touch the origin, it touches the y-axis at 7. This doesn't touch the origin, it touches the y-axis at 5. But here, this is a straight line. And it touches the origin right here. This line touches the origin. So this is the one that is proportional. These are not proportional because they may be straight lines, but they don't touch the origin. This one is also not proportional. Now, if you happen to see something like this, guys, some people will automatically believe that this is proportional because it touches the origin, but it's not a straight line. So if like the one in green that I drew is also not proportional. It's not a straight line, guys. I'm talking about that curve. All right, so let's take a look at the next example. It says the cost of renting video games from Games Incorporated is shown in the table. So as you can see, for one game, the cost is $3. For two games, the cost is $5. For three, the cost is $7. For 4 games, the cost is $9. It says determine whether the cost is proportional to the number of games rented by graphing the coordinate plane and explain. So I'm going to graph. Now you could also find the unit rate to determine if it was proportional or not. So you all know you got to buy a game. You go get your game before you pay for it. So you all know that this is X and this is Y. X is the thing that happens first. So you should know that the number of games is X, the cost is Y. And if you decided to check every Y divided by X or every dependent divided by independent, then 3 divided by 1 is 3. And for the second one, 5 divided by 2 is 2.5. I can tell you right there that's not proportional just by looking at the dependent divided by the independent. Okay, the Y divided by the X for each coordinate. But I'm going to graph it. So I'm going to graph 1, 3 to the right 1 because I know you all don't know this. This 1 is an X. The 3 is a Y. So what you do is you go over to 1 on the X and then you go up 3 for the Y. Okay, that's going to be 1, 3. And you don't have to put these, but I just put you to put those so you can see how I was traveling. All right, so for 2, 5, so you're going to go over to 2 on the X. And then you're going to go up to 5 on the Y, up 5. 1, 2, 3, 4, and 5. 3, 7 is over to 3 on the X. And then you're going to go up 7 for Y. So go up 7. Go up to the number 7 and you're right there. Again, you don't need these. I'm just showing you that so you can see how I'm getting the point. 4, 9, you're going to go to the right, 4 on the X, and then up to 9 on the Y, up to 9 on the Y, puts us at right there. And I'm going to draw a straight line. Now, you would have a straight edge on your desk if I were teaching this in person, and you would just take your straight edge, which would be a ruler, and you would put it against all of these points and then just graph. I'm going to graph it freehand just the best I can. And it looks like it touches the number 1 on the y-axis. Okay. So I can tell from the graph that this is not proportional because it doesn't touch the origin. In other words, it doesn't touch at 0, 0. Doesn't touch right there, guys. All right, it says if it's proportional, write an equation where it's not, so we're not going to worry about it because it's not proportional. So let's go on to the next one. All right, it says the slowest mammal on Earth is the tree sloth. It moves at a rate of 6 feet per minute. So I have units already right here. My units are just, what do I use to measure?
Kayla Mann and Michaela Wood, please report to Ms. Thompson. Kayla Mann and Michaela Wood, please report to Ms. Thompson.
So I can see that feet is feet in minutes. Time has to go by first, so that's X. And that's why you see time, and I need you to put minutes here in terms of minutes. That's why you see time on the X-axis, and feet is your Y, that's your dependent. That's why you see it's distance, but I want you to put feet right here, okay, guys? All right, it says determine the number of feet the sloth moves, whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing it. Okay, so I'm just going to graph. We're just going to look at the graph. I could look at, this is X and this is Y. I could look at the table to see if I keep getting a constant rate. If you looked at a table and it had 0, 0, you would ignore it, okay, to see if it's constant. But so I would do Y divided by X, 6 divided by 1, and get 6. 12 divided by 2, I still get 6. 18 divided by 3, I still get 6. 24 divided by 4, I still get 6. So I can tell that since these rates are constant, it's proportional. But if you want to look at a graph and not the table, so suppose I didn't want to look at the table. I want to look at the graph, so I'm going to plot these. 0, 0, that's the origin. I'm going to put a dot right there. And then you have an X of 1, so you're going to go over 1. And then you have a Y of 6, so you're going to go up 6. And you're going to put a dot right there. All right, and then you have an X that was equal to 2, so you're going to go over 2. And your Y is 12, so you're going to go up 12. Now, I don't want you to get this confused with the unit rate. For unit rate, it's Y divided by X, so it's Y first and then X, okay? But when you plot a point, you plot X first, and then you travel up the Y-axis or second, okay? So it's kind of the opposite of unit rates. Plotting the points is opposite of unit rates. All right, so if I want to plot the point for 318, you're going to go to the right 3. And let me erase these. You're going to go to the right 3 and up to 18 and put your dot. And then we're going to plot 4, an X of 4. So go to the right 4. Let me erase this so you can see how I'm traveling. So you're going to have an X of 4. And then you're going to go up to 24. And 24 is right there. I'm going to put a dot. And then I'm going to take these points and connect them. And I can see that it is a straight line and it does touch the origin. So this would be proportional according to the graph. So if it's a proportional graph, it'll be a straight line and it will touch the origin. If it's a proportional table of values, every Y divided by X will end up being constant, okay? All right, so this is proportional. Says if it's proportional, write an equation and describe the unit rate. All right, so I'm going to wait on that part because you know how to decide what the unit rate is from the table. You all know 6 divided by 1 is 6. 12 divided by 2 is 6 as well. So you know the unit rate, or K, is 6. And you could just write Y equals to 6X. But if all I gave you was this table, excuse me, not the table, but the graph, how could you write the equation from the graph? So I'm going to wait on that and show you down here, okay? So identifying the constant of proportionality, which is also the unit rate, given a graph. Given a table, you just divide y by x and look for your constant of proportionality or your unit rate and attach it to x. Always the thing that happens first, your independent variable. Okay, and you write it in this form. But what do you do when you're given a graph to find the unit rate? Okay, so the constant of proportionality, also called the unit rate, is always the point 0 k, where k is the constant of proportionality, or again, unit rate. So what do I mean? Well, every ordered pair consists of an x and a y. So if you have an x of 0, you can find an x of 0 on your graph, that k is your unit rate. So for instance, sorry, it's not 0. It's 1. That's my fault. If you can find an x value that's equal to 1 and then match it up with the corresponding y coordinate, that's going to be that y coordinate is going to be your unit rate. Okay? So all this means is the y coordinate is the unit rate where x equals 1. So let me show you what I'm talking about. All right, here's x. Here's an x of 1 right here. So if I go up, there's a point, and the y value is 2. So when I have an x that was 1, my y was a 2. Well, whenever you have an x that is a 1, that y is also your unit rate, okay? So that y value was 2, so k is also 2. Your unit rate is 2. Now, I don't really like that method. I'm going to show you another way, okay? So I prefer for you to do this, but that will work when you have an x of 1. When you have an x value that's equal to 1, find its corresponding y value. So the corresponding y value would be 2, so that your unit rate would be 2. Okay, and you need to know what it's talking about. So look at your units. On the y-axis, the unit is price, and on the x-axis, it's number of sodas. So of course, you're going to buy your soda. You're going to go pick your soda out first before you actually pay. So this is going to be your unit rate is dependent over independent, or y over x, and the y is talking about cost or money, and the x is talking about the number of sodas. You can put per between it. So it's basically that unit rate means it's $2 per soda, guys. Always y over x, and on the y is price, and on the x axis is sodas. So it's price per soda. So that's going to be $2 per soda. Now, that's one way to find your unit rate. But another way to find your unit rate says additionally, you can find the constant of proportionality by finding the ratio of y divided by x. And that's what we're used to for any point, and a point consists of an x and a y coordinate, x first. Okay? For any point on the graph, okay? So you just pick a point on the graph and divide the y by the x. And let me show you what I'm talking about. So I can pick this point. I'm going to do it in green. And every ordered pair consists of an x coordinate and then the y. But when you get ready to find the unit rate, all you do is divide your y coordinate by your x coordinate, your dependent by your independent. So the y coordinate is 2. And the x coordinate is 1. So 2 divided by 1 is 2. So that will also give you $2 per soda. And you always look on these axes for your independent and your dependent variables to see what they are. Okay, your units. So you can write dollars per soda, $2 per soda. Now, you didn't have to choose that ordered pair. You could have chosen this one. I'm going to do it in red. So, again, you could have taken your y and divided it by x. So, y is 4. Divided by 2, you still get 2. So, still $2 per soda. X and y. So, that's 6 divided by 3. You still get 2. So, it's still $2 per soda. I don't care what ordered pair you pick. Just make sure you divide y by x to get your unit rate. All right, so with that being said, like on this one, the unit rate was 2. So the equation is in the form y equals to kx. So all you do is replace k. Thank you, Sandy. All you do is replace k with 2. Because your unit rate is denoted k. We'll use the variable k. So it's y equals to 2x. And all that means is, I'm going to use this title, price of a soda in a vending machine. That just means in the vending machine, the cost per soda is $2. Or you can put it costs $2 per soda. That's all that means. Paying $2 for a soda, I wouldn't pay for it. All right, so I'm gonna go back to this one. So on this one, if I want look at the graph only, if I want to look at the graph only, look at this only to determine what the unit rate is or the constant of proportionality. I could say, well, here is an x of 1, and an x of 1 has a y of 6. So I know that that is my constant of proportionality. So the equation is y equals to 6x. I could do it that way. Okay, but that only works if you have an x of 1 and a corresponding y, okay? Now, if you have something you can't read, like if my 1, let me go down here. Let me show you something. You too. Here is an x of 1 as well. But you can't tell what that point is. You can estimate it, but I don't want you estimating, guys, okay? So I only want you to tell me, use an x of 1, use that if you can tell me exactly what this point is right here. And if you can't tell me exactly what that is, don't use it, okay? All right, so another way you could have done it, go back up to this, is you could have just chosen a point. And I'm going to label these points. So every point consists of an x and a y. So this x was at 1, and that has a y of 6. So I could have taken my y and divided it by x, or 6 and divided it by 1, and I get 6. And keep in mind, it's 6 what? Well, it's feet per minute. It's going to be like 10 minutes. All right, it's going to be like, it's feet per minute, guys. All right, on this one, I got to go, this is the point, this one right here, that has an x of 2 and a y of 12. So I can do y divided by x. 12 divided by 2 is also 6. You could have chosen any point. If I go with the red one, that's an x of 3 and a y of 18. And 18 divided by 3 is also 6. You can choose any ordered pair you want to, okay? And just put your units on it. So that's 6 feet per minute, okay? Dependent over independent. Dependent and then independent. Feet per minute, your rate. All right, so for this one, all right, let me go back and write the equation. So we have the equation. That's how you can get y equals to 6x, because you can determine the unit rate from finding an x of 1 and looking at its corresponding y. Or you can use any x and y and divide y by x to find it, okay? And write the equation. There's the equation for that one. Okay, let's take a look at walking speed down here. All right, I'm going to find the unit rate. So to find the unit rate, I'm just going to name an ordered pair because here I have an x of 1, but I can't tell what y that is. I have to estimate it. So I'm not going to use that little trick. What I'm going to do is name an ordered pair. That's to the right 4. That's an x of 4. And that is a y of 2. So what I'll do now is divide y by x. And I didn't have to choose that point. I could have chosen this one, which is 6, 3. Or I could have chosen this one, which is 8 and 4. Okay. But I'm going to go with this one. I'm going to take y, which is 2, and divide it by 4, which gives me 1/2. Now I just got to put my units on them to make it make sense. So my unit, it's always y over x. Y was miles and x was hours. Y is miles, x is hours. So basically it's going to be 1/2 miles per hour. That's what my unit rate means. So somebody's walking speed is a 1/2 mile per hour. I'm going to go ahead and write that. Someone's walking speed is a 1/2 mile. Let me make that look better. It's a 1/2 mile per hour. They can go a 1/2 mile for every hour. So the unit rate is 1/2, and the equation is y equals to 1/2 x. You could have used a decimal 0.5 if you want to. I don't care. It's the same as 1/2. All right, let's look at some verbal descriptions. It says, on a recent trip to Georgia, Todd drove 70 miles after the first hour, 130 miles after the second hour. I got miles and hours. That's x, that's y, because x has to happen first. 200 miles after the third hour, 250 miles after the fourth hour. Determine if the relationship between the miles and the time is proportional. And if it is proportional, write the equation and describe what the unit rate means, okay? So let's just see what the first hour was. Okay, 70 miles, I'm doing y divided by x. 70 miles divided by 1, which means his speed was 70 miles per hour, okay? It's just got to continue to be 70. Let's see. So I'm going to do 130 miles, that's my y, divided by my x of 2 hours. That's only going to be 65. This is definitely not proportional because the rate did not stay the same. Okay, so I'm not going to write an equation for it. All right, a recipe makes 8 jumbo blueberry muffins, calls for 1.5 teaspoons of baking powder. Might be kind of hard to pick out which one is independent and which one is dependent. So let's look for a rate statement in this one. All right, we're going to assume that the relationship is proportional. So we want to write an equation for it, showing the amount of baking soda needed per muffin. So I have a rate statement. Baking soda per muffin. So I can follow this. I can take the baking soda and divide it by the muffins. Okay. All right. So that's going to help me find my unit rate because I need a unit rate to write an equation. My unit rate is K. Okay. All right. So I'm going to take the baking soda, which is 1.5. I'm going to use the division symbol, divided by 8. So I'm going to use the C method here. 2 times 1 is 2, plus 1 is 3. That's 3/2 divided by 8. I'm going to put 8 over 1. And then I'm going to do keep, change, and flip. So I get 3/16. And then I just need to keep it as 3/16 baking soda. 3/16, and then it's going to be teaspoons, guys. 3/16 teaspoons of baking soda per muffin. Now the equation is y equals, you're going to change this. k to whatever your k was, which was 3/16. Y equals to 3/16 x. Just attach it to x, so you're an independent variable, okay? Always attaches to your independent variable, your unit rate does. Okay, let's take a look at the last one. It says Chase can run a fourth of a mile in 2 minutes. Well, I know this is x, and that's why you got time has to pass by before you can do anything. We're going to assume that his speed is constant, which means if it's constant, it's proportional. So we're going to assume it's proportional and write an equation that shows the proportional relationship between distance and time. Okay, so again, I'm just going to take y and divide it by x. Since it's got fractions in it, I'm going to, and that's k, guys, which is my unit rate. And I can write the equation y in the form y equals kx. But I'm going to use my division sign. My y is miles. So I'm going to do 1/4 divided by x, which is minutes. So divided by 2.5. I'm going to use the C method right here. 2 times 2 is 4 plus 1 is 5. So that's going to be 1/4 divided by 5/2. Then I'm going to keep, change, and flip. So I have 1/4 times 2/5. That gives me 2 on the top and 20 on the bottom. I can simplify that and divide them both by 2. 2 divided by 2 is 1. 20 divided by 2 is 10. So a tenth. A tenth what? A tenth of a mile per minute. Miles per minute. So Chase can run 1/10 mile per minute. As a decimal is 0.1, okay? But now you can just write this as 1/10 x, or you can write this as 0.1 because that's 1/10 too. And that's your equation because you're just replacing k with your unit rate, and that's my unit rate either as a fraction or a decimal, okay? And that's it, guys. Thank you.